Hello learners, this is Education Online Program. I'm teacher Lily and the subject is chemistry and our topic is Ionic Equation, and this topic is for senior 3 and 4. So here we are, if you are saying Ionic Equation, it means there is a full equation or chemical equation that you have written already. So you need to know the Ionic Equation. Here, if we said Ionic Equation, it means in a chemical reaction taking place in aqueous solutions involve at least one ionic species, either as reactants or products. So here we have to remember that in a chemical equations there are ionic equations. So here we say that when ionic solids are dissolved in water, the ions become separated and move freely in the solution. So in this case, we have to remember that there are solutions which can be dissolved and it forms ions. So in this case, we say that the ionic species formed are called the ionic equations. So this equation here, we write it as ionic. So in this case, we say that there is ionic equation, there is full chemical equations. So ionic equation here, we can say that ionic equation ionic equations are simply representing representing the ionic species in a chemical reaction, So in a chemical reactions, so we shall have the ionic equations are simply representing the ionic species in a chemical reaction, because in a chemical reaction you can have some reacting species as aqueous solution. So when you dissolve this aqueous solution, they will dissociate into ions, and this we call them as ionic species. So the solids are dissolved in water and they also form ions, and this also represent them as ionic species, and they are written, or in their chemical equation we write them as ionic equations. So during reaction involving ions or ionic compounds, some of the ions may not take part in the chemical reactions. So in a chemical reaction, there are those species, or there are ionic species that are not participating in the chemical reactions. So we call these species as spectators. So these species, we consider them as spectators ion, and this we say they are known as, so these are called spectators ions. So in a chemical reaction, we have ionic species, and they are represented as ionic equation. In a chemical equation, we represent them as ionic equations. So also we have to know that there are those ions that does not participate in the chemical reaction. So in this case, we call them as spectators ions. They are there, but they are not shown out. So we call them as spectators ion. So in this case, ions which exist in a chemical reaction process but do not take place, but do not take part in this reaction, we call them as spectators ions. So spectators ions cancel out and are therefore not shown in the ionic equations. So these spectators ion, they are not just there as spectators, they exist, but they are not taking part in the chemical reaction, and we consider them to cancel out when we are dealing with the ionic equations. So we say that the spectators ions, spectators ions, spectators ions, spectators ions cancel out in the ionic equations. So the spectators ions cancel out in the ionic equation. They are there, but they have to cancel out in an ionic equation. So when you are representing the chemical equation, we need to remember that there is ionic equation, and we have to know that there are spectators ions in this ionic equation, and they usually cancel out when you are dealing with the ionic equations. So here we said and are therefore not shown in the ionic equation. So when they cancel out, it means that we have a total ionic equation. You represent them all there, but when you come to the half ionic equation, it means here we cancel them out and we don't represent them in the half reactions. So for example, you can have an example. We can say that hydrogen chloride, which is aqueous in solution, plus sodium hydroxide will be equals to sodium chloride plus water molecules. So we have seen that sodium hydroxide and hydrochloric acid, these are acid-base reaction, and they neutralize to give us salt and water. So sodium chloride here is a salt and water is the byproduct. So we consider sodium chloride as aqueous solutions. So we shall say that in this reaction there is ionic reaction. So this ionic reaction, we shall say that it is, we are seeing hydrogen ion, and we have chloride ion, we have sodium ion. We have to dissociate the aqueous solutions. By dissociating the aqueous solution, then we shall see which ones are spectators and which ones are not. So hydrogen ion, in this case, it is a proton, plus chloride ion, which is an anion, plus sodium ion, and we have hydroxide ion. So these are the ions at the reactant site. The ions at the reactant sites are sodium ion, hydroxide ion, chloride ion, and hydrogen as a proton with the positive sign. So we shall have at the product site is sodium chloride. We are going to dissociate it because it is an aqueous solution, and we have positive chloride and we have a negative sign at the chloride ion. So all of them are aqueous solution that dissociates. So water will remain as it is because it is a molecule. So molecule doesn't dissociate into ions. So we shall have, now we have to see the ions at the product side and the ions at the reactant side, and we cancel out the spectators. In this case, the spectators are a chloride ion and sodium ion. So we shall have to cancel chloride ion in this side of the reaction, and then on the other side of the reaction. Again, we see which one is a spectator. Sodium ion is an spectator, and also we cancel it at the product side. So now this is known as the total ionic equations. So we come out with the hydrogen proton plus hydroxide ion. It will give us water molecules. So here we have seen that this is now the ionic equation for the reaction of sodium hydroxide with the hydrochloric acid to give us sodium chloride plus water. So in this case, the spectators in this reaction, or on the both sides, we consider them as chloride ion and sodium ion. The spectators ion, therefore the spectators ions are hydrogen, sodium ion, and we have chloride ion on both sides of the reactions. So on both sides of the reaction, we have sodium ion and chloride ions. So therefore, each of them cancel each other because they are in both sides of the chemical reactions or chemical equations. So the ionic equation here is, so hydrogen ion, which is a proton, and hydroxide ion to give us water molecules. So here in writing ionic equations, we need also to follow some steps. At least we shall have a clear ionic equations. So here students find it very difficult to calculate or to form the ionic equations. But here when you have the steps, at least it will be very easier for you to get the ionic equations. So we shall do that one by writing that in the steps in writing ionic equations. Step in writing ionic equation. First of all, you need to balance the equation. As you have seen, the equation above is balanced, and you see that the atoms at the right hand side is the same as the atoms at the left hand side. So we shall have, the first thing is to balance the chemical equation. You need to balance the chemical equation. Balancing the chemical equation, we have seen this one before, that you count the number of atoms at the right hand side with the number of the atoms at the left hand side. If they are not equal, then you add some numbers at least to balance the atoms on both sides of the reactions. So here we balance this equation, the chemical equations, in terms of charges. In terms of charge or ions. In terms of charge or ions or moles. So the second step is also to write the second step of writing the ionic equations. So we shall say that the second step is for you to know the ions that are reacting. So include state symbols of the reactant. So before you go ahead, you need to include the symbols of the reactant. So in this case, the physical state of the reacting substance, you need to indicate them by putting them inside the bracket. As you have seen in this example, we have hydrochloric acid as an aqueous, so we have indicated its physical state, and also we have seen in water it is represented by a small l. So include state. So number 2, we include the state symbol, of the reactants and the products. The state symbols of the reactants and the products. So formula unit of the ionic solid. So number 3, you have to show the formula unit. The formula unit of what? The formula unit of the solid. The ionic solid, sorry. We have the ionic solid. So we have to form the formula unit of the ionic solid. So the formula or the formula of the unit formula unit of the ionic solid. Number 4 is to identify substances containing free ions and those that do not. So number 4, we need to identify the substances. Identify the substances containing it. In this case, we have the reacting substance. For example, here we have hydrochloric acid. We identify it as ionic substance. So we identify the substance containing ions. That is moving freely. So in this case, the free ions, and those that do not. So in this case, you need to have a hint for getting the free ions, for knowing which substance contain or can form or dissociate into free ions. So this containing free ion, the substance which containing free ions, we can have. So we need to say that the substances containing free ions, first of all, you have to consider them as what? As aqueous solution of salts, are aqueous solutions of salt. Aqueous solution of salt, they can have free ions when you dissolve it to a solvent. They can have free ions, and also acids and bases. So in this case, we have the ions or the free ions. You can get them in aqueous solution of salt. You can get them in aqueous solution of acids, and also in aqueous solution of bases. So there are those that do not contain free ions. So there are the substances that do not contain free ions, or when you dissolve them in a solvent, will not form free ions. They are insoluble salt. You can have insoluble salt. So this can help us as a guide to know which substances can dissociate to form free ions. So we say that here we are going to show the second one. substances that do not form free ions. We can have them as salt. We can have them as insoluble salts. It means the salts that when you dissolve them in a solvent, either water or any other solvent or any organic solvent, they do not dissolve. So here we consider them as they are compounds or substances that cannot form free ions. So we have insoluble salts, we have gases, we have molecules, and lastly we have insoluble salt. We have insoluble salt first, and we have insoluble bases. So these are the substances which, when you dissolve them in a solvent, they will not form free ions. So in this case, these are we say that they are compounds. They have to identify them when you're dealing with the free ionic equations. So the ionic equation here is not so easy for you to equate it, but you need to go into the steps to know where to get those ions which can move freely in an aqueous solution. So we can say that, so here we identify the substance containing free ions and those that do not. So the substance containing free ions, we have identified them as aqueous solutions of salts, can be aqueous solutions of acids, and can be aqueous solutions of base. So in this case, when you have this kind of substances in a reaction, then they can form free ions. Also, we can also identify those which are not forming free ions, and these are not the ones we can have is insoluble salt and insoluble bases. We can have gases and we have molecules. So learners, you have to remember all this by when you are dealing with the chemical equations or ionic chemical equations. So for example, you'll be given an aqueous solution. Here, when you're given an aqueous solution of barium, you need to remember, is it soluble salt or not? So an aqueous solution of barium nitrate. So in this case, if you have barium nitrate, the chemical formula is like this, and we represent it by having 3 atoms. We have barium atom, we have nitrogen atom, and we have oxygen atom. So we shall say that here we have barium, the aqueous solution of barium nitrate and sulfuric acid. We shall have sulfuric acid. So these reactions will give us barium sulfate and nitric acid. So we shall have barium sulfate plus this byproduct. So this we call it as the full equation. So the full chemical equation is this one. So we have to check whether it's balanced or not. So we need to balance the number of the atoms at the reactant side, and we balance with the one at the product side. So in this case, we shall say 2 atoms of hydrogen are not balanced. So we shall put 2 at the side of the product. So we form the total ionic equation. So the total ionic equation will be, we need to dissociate this substance which is aqueous. So in this case, this will form ions. Sulfuric acid is also aqueous. It will form ions. And barium sulfate is also aqueous, sulfuric acid is aqueous and barium sulfate is solid. So in this case, this is not going to form an aqueous, an ion or free ion. So we can have nitric acid as aqueous because it is an acid, and we consider it as one of the substances that can dissociate to form ions. So we shall have barium, which is positive 2, plus nitric with a negative 1, which is also aqueous, plus hydrogen gas in this substance of sulfuric acid, plus sulfate. In this case, it is also aqueous. So in this case, we shall have all these substances, they can dissociate to form ions. Why? Because they are all in aqueous solution. So what dissociates in this side is only nitric acid, and the other one remain as it is. So we shall have hydrogen ion, aqueous, plus nitric, aqueous. So what cancel out, which is known as the spectators, is nitrate and hydrogen. So when you come to this side, we shall have nitrate and hydrogen. So those are considered as spectators. So the equation here, the half ionic equation will be barium plus sulfate will give us barium sulfate, which is a solid. So in this case, learners, we have come out with the ionic equation for this full chemical equation. So we have identified the ions which can dissociate, and we consider those ones which are in aqueous form. So here in this case, you need to remember that when you have a balanced chemical equation and you indicate the symbols or the physical states, then you will know which ones can dissociate and which one cannot dissociate. So ionic equation is very important in a chemical reactions, because it will show you which ions are spectators and which ones are not. So with these learners, we have come to the end of this lesson and our ionic equation, and we need to remember them whenever we are dealing with the chemical reaction. So thank you very much, and teacher Lily.